Hi everyone, in this video we will discuss a nice question on remainders. The question says, what is the remainder when 3 raised power 2024, so this is a very big power, is divided by 5. Now we will solve this question in two ways. Let us first discuss the method 1. Method 1. Now in this method we will use a concept known as cyclicity. Right? Okay. Now what does cyclicity say? Now cyclicity means that there will be some repetition or there will be some pattern when I try to find the remainders when I divide by 5. So let's say I will start from the smallest power, 3 raised power 1. If I divide this by 5, then what is the remainder? I will note down the remainders here. So if you divide 3 by 5, you will get the remainder 3. If you divide 3 raised power 2 by 5, you will get the remainder. So 9 by 5, remainder will be 4, right? 3 raised power 3, if you divide by 5, so 27 by 5, remainder will be 2. Fine. Now let me move to the next power, 3 raised power 4. So the remainder will be 1, right? Now here comes the interesting part. 3 raised power 5 divide by 5. If I divide this, then I will get the remainder 3, right? 3 raised power 6. Okay, let me take it. Divide by 5. The remainder will be, so you can multiply this by 3, so you will get remainder 4. Now if you notice here, there is a pattern. And what is that pattern? So there is this pattern from here. If you notice, my remainders have started getting repeated, right? 3, 4, 2, 1, again 3, 4. Now if you go to 7th power, then again you will get 2. So after a cycle of 4, my remainders have started repeating. So can I say that there is a cyclicity, right? There is a cyclicity in remainders. And what is the cycle length? Cycle length is 4, right? Now how does it help us? So it helps us immensely. Now what I will do is, in other words, any power of 3, any big power of 3 can now belong to one of these 4 groups. They will have to belong to these 4 groups only, right? Irrespective of how big the power is, they will belong to either 3 raised power 1, 3 raised power 2, 3 raised power 3, 3 raised power 4. So their behavior will be among one of these, right? And now how will I find that what is the behavior? So what I will do is, I will try to find, I will divide this power by 4, I will divide this power by 4, and I will see what is the remainder, right? So if I divide this 2024 by cycle length, right? What is 4? Cycle length. That's why I'm dividing this by 4. So if I divide this by 4, what is the remainder? Now you must have known that the divisibility rule of 4 says that the last 2 digits, if it is divisible by 4, then the whole number is divisible by 4, right? So I don't have to worry about these digits. So 24 divisible by 4, so obviously it is divisible. In other words, the remainder is 0, right? Now tell me one thing. This power belongs to remainder 0 class, right? So which class this power will belong to? Now which of these powers will give me remainder 0? So obviously 4, right? So this big power actually belongs to 3 raised power 4. 3 raised power 2024. Actually it is equivalent to 3 raised power 4. So in other words, my remainder is going to be 1. So finally our answer is 1. Okay. Finally our answer is 1. Now this was the method 1. Now in method 2, what I will do is, now there is second method. So let me start the second method. Okay. Method 2. Now in method 2, I will use a concept known as negative remainders. Now what does negative remainder say? So I will give a brief overview of that. So let's say if I divide 30, let's say 35, okay. If I divide this by 6 and if I ask you what is the remainder, so you will say that remainder is 6 into 5, 30 plus 5. So 5 is the remainder, right? But there is another way to represent this remainder actually. I can say that there is a remainder of -1 also. Why? Because you can think of this problem as groupings, right? So when I divide 35 by 6, in other words, what I want to find is that I want to divide 35 items. I want to divide 35 items into group of 6 items each. Okay. So this 5 denotes that there are 5 left items which cannot be used to form any group, right? So there will be 5 complete groups, 5 complete groups, 5 complete groups plus 5 extra, right? Now since I need 6 items to form a complete group, I cannot make a complete group of 5, right? Now what does this -1 denote? Now tell me one thing, if I say that how many items do I need more to form a complete group? So I have already 5. If I get this 1, then obviously I can form a next complete group, right? So negative remainders, in order to find negative remainders, what you will do is you will find the positive remainder and you will subtract the divisor from it. So 5 minus 6, you will get -1, right? Now let me take a quick example, another quick example. So let me take, we can take, let's say 47 by 7. Okay. If I ask you what is the remainder, so you will say 7 into 6, 42. So 5 is the remainder, right? And if you want to find the negative remainder, what you will do is you will take this positive remainder and you will subtract the divisor from it. So 5 minus 7, -2. Okay. Now another way to look at this is you got 6 as the quotient, right? So what you can do is you can take the next quotient. Next quotient will be 7. So 7 into 7, 49. Now you can subtract 49 from this dividend. Okay, so 47 minus 49, you will again get the -2. But the better way is this one. Okay, so you can find the negative remainders easily. It is not that hard. Now how can we leverage that? How can we use this technique here? So we can use this technique very smartly here. What I will do is, so we have, so our question says 3, okay, let me, 3 raised power 2024 divided by 5, right? Now what I will do is I will try to find a smaller power of 3 which will give me either a remainder of +1 or -1, right? Why? Because any power raised to these numbers will be easy to find, right? Any power of 1, any power of +1, I know that this is going to give me 1. Now for -1 there will be 2 cases. If that power is even, then I will get 1. If that power is odd, then I will get -1, right? But even and odd, finding even and odd is very easy for howsoever big the power is, right? Right? Because even or odd can be found out by simply looking at the unit digit of the power. Okay, so that's why it is a very good technique actually. Okay, so now what I will do, so which power of 2 will give me +1 or -1 remainder? So 3 raised power 1, if I divide this, then I will get 3 remainder. 3 raised power 2 by 5, so I will get 9, so 4 remainder, right? But can I say that this is nothing but -1 remainder? This is equivalent to negative remainder of -1, right? Right? 4 minus 5, this will give me -1. So this -1 can be used here. So in other words, what I can do now is I can rewrite my powers. One second. 3 raised power 2024. I can rewrite this as 3 raised power 2. Now obviously this is divisible by, now I don't need to, it is easy also, 1012, but even if I don't, actually if you don't calculate this, then also it is okay, right? You can simply write this as 3 raised power 2 k, okay, divided by 5. Fine. Now this 9 will give me -1, so -1 raised power k by 5. Now only thing I am concerned here is that what is this k? Is it odd or is it even? Right? Is it odd or is it even? So obviously this is even. So this is even. right? So this will give me 1 by 5. So can I say that the remainder is 1, right? So finally I got my answer as 1. So this was the method 2 in which we use the concept known as negative remainders, right? Now let me move on to the topmost question. So this was our question. This was our question. And finally we solved using 2 methods and we got our answer as 1. So this was a good exercise actually. You learned 2 concepts here. One was the cyclicity concept and another was negative remainders. Both are very important in terms of finding remainders of higher powers. You will frequently use these techniques, right? So I hope you like this content. So thank you.